So I do want to proceed with the last but not least, Matthew. Matthew will talk about the application security testing tools, consolidation. You know, we talked about lots of things, lots of security tools that eventually needs to be, there are lots of complexity when you're using those kind of tools. It could be process-wise, technology-wise, combining those technology and processes. So we will talk about how to reduce the complexity and the total cost of ownership with the ASPM. Just a background on Matthew. Matthew joined Synopsys in 2018 as a sales engineering manager. Prior to that, he had worked with a security professional at Cisco and AppDynamics, Hewlett-Packard, HP, so in a huge enterprise with huge R&D teams, I suppose. Matthew is also the subject matter expert of software supply chain. So all those third-party vulnerabilities, Matthew is the subject matter over there, and can elaborate on that further on. So Matthew, you have the presentation, you have the control, and you can.
Thank you very much. Thanks, Lior. So great to talk to you all today. I hope this is going to be as interesting as Avi's section and Tamir's section. So let's see. I am trying to click the slides. There we go. So I don't think you need to see me to read an agenda. You can read that yourself. So I will click straight through it for the purposes of simplicity. So we're talking about tool proliferation here, and I thought a nice analogy would be around development tools. So this is not Appsec, but it's the history of development tools, and we all know and love this. Going back into the, I mean, I go back before Java, but C and C++ and Java were, pretty early examples of application development. There are many more, as we know, but over time, many more things have come in, more package managers, more environments for coding, things like Visual Studio, IntelliJ, Jenkins, and Jira. Puppet and Chef for deploy, Datadog, and many other tools for operating and log analysis and so on. And again, more names. And the truth is, as you can imagine, this is going to end up very complicated. And frankly, if I was to do this properly, there wouldn't be enough room on this slide to show all the little icons of the different customers, if you know what I mean. So the point to make is that this is much more complicated than it used to be. And what we're seeing is the same in application security. So this research from the Enterprise Strategy Group shows that 70% of organizations that they questioned have more than 10 separate AST tools. And this is an analog in a Gartner analysis that shows that this also correlates to lots of different vendors of those tools. So 43% of organizations have more than 10 different security vendors. So this is definitely a thing. And what we have seen is that organizations are suffering from lots of different tools and lots of different vendors. Now, this may not be a bad thing. I mean, I actually think that proliferation of tools is not a bad thing, but it does complicate the process of trying to manage security in applications. Now, if we're going to talk about application security, the elephant in the room is the supply chain. And you can imagine why I'm talking about this, because my subject matter area is the supply chain. And this report from Forrester in 2023 is from organizations, CISOs, who have responded about, have they had a hack, a breach in the last year? And if so, what were the causes? And we see here, I mean, first of all, these numbers don't add up to 100%, I guess, because there are multiple causes, but there are also multiple hacks for organizations. They've been breached multiple times. But essentially, we can see that at the very top of the chain there are the software supply chain breach. And then next to that is the vulnerability exploit, essentially open source, which is exactly the same to me. I mean, I think they're very similar. I'm not sure what the difference is there, but they did make a distinction. And if we then look at the things that we normally think of as application security, you know, analysis, things like web application exploits, injection, cross-site scripting, and so on, that's only 16%. So it's important, but the supply chain is certainly the most exposed surface for these sorts of issues for application security. So we need to get a grip on the supply chain. And it's useful to reflect on some recent history as to why we are where we are and what's happened in the legislature as well. Because if we're going to, you know, have a proper application security process, then we need to be able to respond to requests from the legislature. So you probably all remember these, but Equifax in 2018, 2017 had a pretty standard single breach of a major system that they failed to upgrade for 6 months, Java Spring, I think it was. And yeah, they lost 137 million credit records, and they were fined $700 million by the regulator as a punitive level of punishment to stop them doing it again. And that's a traditional individual supply chain hack. But then we moved to SolarWinds in 2020. And SolarWinds, as we know, was a supply chain hack. They got into the development environment and they managed to modify and add malware to the SolarWinds software. And we don't know a lot about this because a lot of the organizations that were affected are governmental and defense. What we do know is that 18,000 organizations downloaded the vulnerable application and deployed it in their network. So this is a very large number of affected organizations. And as I say, that includes most of the US federal government, large number of EU organizations and national governments inside the EU and elsewhere, and including Microsoft and other people. So the scale has gone up, as you can see there. One issue, many affected customers. And then we moved to 2021 with the Log4j issue, which again, and there's more recently, as we know, we've had many more since, but Log4j just again shows the scalar multiplier that we've had. So Log4j, a very common Java framework, also used elsewhere for logging, and again, virtually all Java web servers were affected by this. And again, we don't know how many people actually lost data because it's just too large, but we do know that at peak, mid-2023, there were more than 10 million requests an hour to break into applications to using Log4j. So we're talking hundreds of millions of websites affected by a single or a series of critical issues which were simply not identified. And that led to the cybersecurity executive order from the White House, which was the first major, legislative piece of information that said we need to do better, and that has then subsequently led to many more things. Now, I've got another slide coming in a minute where we'll talk about what those things are and what we need to do and why we need to do a better job of application and other security. But some other data that we can talk about here on the supply chain, and again, you can read it yourself, but we're talking huge increases in supply chain attacks. Most components that are downloaded from public portals are vulnerable, and most organizations, 45%, nearly half of organizations will experience attacks in 2025, okay, so or up to 2025. So we're talking about a very large attack surface of a large impact. And again, I could go through those examples with Airbus, Norton, and Microsoft, but I'm not going to. You can look them up yourselves. So as I say, this has led to some legislative changes, and I think the slide has not actually shown up, so we'll jump past that, or perhaps it's coming later. I've forgotten the order. But we've talked about a lot of this already. We've talked about, with Avi, we were talking about threat modeling and we were talking about various things. It's useful just to assess what are the processes that we can put in place for application development? And here are some of them. These are the manual processes, which can be tool assisted, but generally manual expert led, including pen test, including threat modeling and others. And here are some of the things that you can do in tools. And you can see lots of different things. There's static analysis, composition analysis, config analysis, interactive, infrastructure, vulnerabilities, dynamic, container, malware secrets, network fuzzing, and so on. So all of this stuff theoretically should be being done. And some of it can be done by one or more tools, but many of these things require individual capabilities to do it. And so the problem that we actually have is that we have all of these stages of our development, and we have lots of security tools, an example there, and they're producing these sorts of issues. So the issues are far too many results, I mean, just off the scale in terms of understandability, data being stored in multiple different places, so lots of different databases and user interfaces and so on, many of which are overlapping. They may be the same, or they may be reported by different tools in different ways, all of which are inconsistently scored. You know, a critical issue in one place is a low issue in another. Obviously, the additional requirement to add manual data, and that could be issues which need to be looked at from threat modeling, but also pen test data or individual issues identified that need to be added. And of course, if you've got lots of tools, you've got lots of integration points as well. You need to put this into your pipeline, put it into your IDEs or whatever it may be, and you've got all of those fragile integration points, which have to be unwound if you need to make a change. And of course, that leads to vendor lock-in. You can't make any changes. You can't move to the best product. You can't do very much. Okay, so really serious issues. And again, it does depend on the organization, but much of this work is being done by security engineers, or perhaps by security champions inside the sort of agile development process. But there aren't enough of them, and there aren't enough skills. Okay, so we literally don't have enough knowledgeable application security engineers, or even security champions who know how to do this. And frankly, this shouldn't be a developer problem. Let's be clear, and it's a point I make in different presentations. We can't blame the developer for everything. Do you know what I mean? The responsibility to manage organizational application security or IT security is not just the developers. It's everybody. This should not be shift left. This should be shift everywhere. Okay, and this idea that you can constantly make the developers responsible, they've got a job to do, and they've got enough on their plate, they've got enough going on. And the other, of course, the other alternative is shift right, moving it to the operations team and making it their problem. But this is not true. It has to be everything, shift everywhere, and everyone becomes responsible. Oh, there we go. There's my slide. It got out of order, or in my head it got out of order. But what are the drivers that we've got? Well, clearly, Gartner is saying we're all going to have to be producing software bill of materials. So we're going to have to know exactly what's in our software for our customers. And then, of course, huge amounts of new legislation. NIS2 and DORA from the EU. I don't know if you're aware, but I was at a conference in Copenhagen last week, and NIS2 requires that all suppliers of services and tools to critical industry in the EU are required to register in the EU and provide a representative and then comply with all of the regulations. Otherwise, you will not be allowed to operate in the EU. So this may not be, Israel specific, but if you're supplying anybody in the EU on NIS2 is for critical infrastructure, and there are 18 sectors, including banking, food, electricity supply, transport, loads of things. I can't remember them all. So almost certainly some of us are affected. And then DORA is very much the same and more specific for financial inside the EU. And both of these carry huge punitive damages if you don't comply. So they are really serious problems. And then other things there, we've got the Cyber Resilience Act coming along from the EU, probably going to be made into law next month, and that will become a thing, probably requiring SBOMs. And all of these require organizations who are in the supply chain to publish vulnerabilities to their customers and to the CSIRTs, the national CSIRTs, to tell them that they have these vulnerabilities in their services. So we need to get a bit of grip on this, and I don't need to read the rest of the slide there. You can do it. So all of this is driving organizations to try to move away from individual tools and moving towards a consolidation platform. Okay, so, and again, you can read the slides there. So the vast majority of organizations are considering consolidation in 2023, and I'm sure that number has gone up more recently. Okay. So what are we talking about in terms of why people want to consolidate? Well, obviously, people want to move faster, and so the consolidation will increase your velocity by reducing friction. It also gives you that overall risk posture on applications and other areas and reduces risk, allowing you to work out where you've got your critical areas for focus. And it clearly gives you decreased costs because you can, if you want to, reduce the number of vendors and you can reduce the overhead. So my job now is to talk about why or how we do this. But I think a question came out at the beginning, if you remember, what's happened? What are these acronyms? Where have they come from? What's ASOC? What's ASPM? Where did they come from? Well, we can thank our friends at Gartner. Okay, perhaps they have too much influence, but here we have the hype cycle for Appsec in 2019. Okay, and we can see in the top bar there, moving up towards the peak of inflated expectations, is ASOC, Application Security Orchestration and Correlation. Fantastic. Okay, it seems quite reasonable. If we look at 2022, that has now moved over the peak and is moving down towards the trough of disillusionment. By the way, I love this graph. With this, it doesn't mean the tools are useless or the capabilities useless. It means that there are overinflated, capability, expectations at the beginning. But there they have application security orchestration correlation moving down the other side. Fantastic. Lo and behold, in 2023, they got rid of it. It disappeared without a trace and was replaced in a different place in the cycle with ASPM. Okay, and that's really a Gartner thing. So what is ASPM? Well, it is an alignment to the other PM's posture management tools for cloud data, and I think there are other ones as well. So ASPM is application posture management, essentially. If we also look at what ASOC was focused on before, it has expanded the scope a little bit. What we're seeing is, that it was orchestration and correlation focused only really on vulnerabilities in the development workflow, but ASPM expanded to cover development and production and provide prioritization and some other capabilities. So it is a slightly enhanced capability on ASOC. Okay, so ASOC is dead, long live ASPM, according to Gartner. Good. So what do we need to do about this? What's the answer? Well, I have coined a new term, and that term is Asianization. Okay. So we have the problems here, data and lock-in and so on, all of these things that we were talking about earlier. And really the solution is a lot of Asians. Okay, so there they all are. Again, I don't need to read them, but there are a lot, and they are there for a reason, except risk management, of course. And I couldn't find an Asian that is risk management. If somebody thinks of one, then please let me know, because it ruins the the wording there. But anyway, let's go through some of what these are and what they mean for you and how you can use them. Okay, now I've taken the liberty of putting our own ASPM solution in the middle of the slide here, because ultimately we are a commercial organization and they do have to pay my enormous salary. So we have to sell something eventually. So anyway, our ASPM solution is called Software Risk Manager. It is a mature product that has been onward developed from an ASOC solution as was. Okay. But what it can do is, the first thing it can do is you run scans in your pipeline, and those scans might be using an open source tool or a tool that produces an artifact. So it's not stored anywhere, it happens in the pipeline like a JSON or a XML or something else, and it produces information that you might be ingesting in the pipeline. Well, Software Risk Manager can simply pull that artifact and get the results. Okay. Alternatively, you can also point it at a server. So you may have a tool server that's doing static analysis. You may have a separate one that's doing SCA, another one that's doing DAST, and so on. Or you may have some overlaps there, but you've got multiple tool servers. You can literally point them at Software Risk Manager at the tool server to aggregate the data across multiple projects, okay, in one go, and do that regularly as the tool server is updated. So initially, we're not talking about replacing the tools, we're talking about aggregation. Or here you can see consolidation, correlation, and deduplication. And clearly, you can also add in data from pen testing by import, manual issues, which you can create either by API or manual GUI, and network infrastructure testing, and many more, container testing, threat modeling, anything that you want in terms of issues which need to be remediated and added to a project. And the output is that you then create a project, a hierarchy of projects. We'll talk about that in a minute, automatically in Software Risk Manager, and then you'll get a whole bunch of issues. And if you've got multiple tools, they may overlap. There may be issues which are, static analysis, hence SAST, vulnerabilities for components, or component-based issues, or IP issues for network. And clearly, what the tool can do, I mean, it's not magic, but what it can do is where those issues are at the same point in the code, of the same type, it will aggregate them or can aggregate them. So you end up with fewer issues, reducing the noise. So that's the deduplication and correlation piece. Okay, so that's the first ASIAN. The next ASIAN is orchestration. And this really is an alternative to the onboarding process that we've talked before, or an adjunct. You can use it as well. So in this case, you can point the ASPM solution at your software control system, your SCM, and onboard the code to the solution, and it will then run its own scan called a pre-scan, and optionally it will identify what's in the project, what language, package manager, environment, whatever may be necessary, and you can set custom rules for that as well. And then if you want, you can use extra containers to actually run analysis, okay? And that could be SAST analysis, SCA analysis, or any other static or type of scan that can be done on the code that's pulled from a repository. And that can include open source or commercial tools. And of course, we have the ability to slot in our SAST and SCA solutions there, including Coverity and Black Duck, if you've heard of them. And then what that will do is it can supplement the project data that you may be getting from elsewhere. So what does this mean? If you don't have certain types of scan, and you've got data from pen tests or whatever, you could simply point at the SCM and scan that into the tool, the ASPM, and then have that run some extra data to give you new issues without any overlap there. Good. Okay, so the next thing to say, and I see there's a question there. We'll come back to that question later if that's okay, because it's a bit specific. The next thing is prioritization. So prioritization is essentially, you're going to get a lot of noise. You're going to get a large number of issues. Clearly, they will be deduplicated where possible. They will be aggregated where possible, but there will still be a lot of them. So what you need to be able to do is to start to identify issues of criticality that need to be addressed. So custom filters are required to point at the issues and create policies, and then set, most importantly, dates. Okay, so you can say on a per project basis, if you have a critical issue and it's not dealt with within 2 days of being identified, then violate a policy. Do you understand? So that allows you to put some time-based factors in there, because you do need to give some time for someone to do something. This can't be immediately escalated to a policy violation. So that's very important and a useful factor for managing that, and that's really the prioritization piece. The next one is escalation and aggregation. So what we're talking about here is that you've got a software risk or ASPM solution. Obviously, other ASPM solutions are available, and you can import the issues. And what you can then do is you can set up bidirectional ticketing with your ticketing system. So in project one, you would set up a connection to a Jira project to say that's my Jira project, and you can put project-specific rules, which you will need in Jira because it's far too configurable. It'll have different statuses by project. So you can say, this is what you need to do with this ticket for this project, or you could use more global rules. But again, you can do that heterogeneously across multiple ticketing systems. For example, ServiceNow, GitHub, and Azure DevOps and GitLab are also supported, okay? But the important thing is you can then also set reverse rules such that when the ticket changes status, it updates the issue status inside Software Risk Manager. So this means that you don't need to have a close integration of the ASPM solution. If the ticket is fixed, you could have that reflected in the ASPM solution Software Risk Manager and updated in real time. And that's really important because, again, this has to be as lightweight as possible. You don't want it too heavily integrated into the pipelines. Now, how do you actually get this moving? How do you get people notified about what's happening in the ASPM solution? Well, we've talked about bidirectional ticketing, so you can actually see that, that you can create tickets. They typically go to developers, although they can go elsewhere. And then what we would want to do, though, is we also want to update developers about other issues, which have not been created tickets from, so they can see everything. This would allow them to see issues from the pen test phase, or issues which need resolving from the threat modeling, or static analysis from other tools, or container analysis, or anything, any of the 150 different tools which can be integrated and data, do you understand, including manual issues. And that's important because they literally can connect to a project in Software Risk Manager and see it directly in their IDE without going anywhere and say, well, that's really strange. Why is that pen tester doing that test? They've done something, they've escalated an issue. Oh, hold on a minute. Oh, I forgot something. Or of course, they can go in and mark it as a false positive or something. And there are approval workflows if they want to do that. The next thing is, of course, that you really want to have that information then escalated to security champions and managements. And that's where you need things like hierarchical reporting of any depth. So you need to have aggregation into projects, into applications, into types of application, into geographic areas, however you want to aggregate those in a hierarchy, and then showing all the issues across the hierarchy, so you can see the trend that things are going in the right direction. So that's reporting and dashboarding. Obviously, we've talked about policies which can be applied, and clearly lots of nice reports that you can get out of that to send to your stakeholders or your external customers if you wish. So that's important around communication and risk management as well. So how does this work in practice? Well, the theory is that what we want to do is we want to take a set of tools and we want to move them to a new set of tools and have a very easy life. But unfortunately, reality really isn't that way. What happens is when we try to do this, we often find that there are differences or tools that don't suit. We find that there are anomalies. It can take time as well. Clearly, you've got individual integrations, and clearly getting to that, you have to put sticking plasters on. That's what that's meant to show, and then you can end up with a final position. But clearly, it's really not that simple. It's very noisy and difficult, and replacing individual tools, especially across the numerous number that you may have, really isn't going to be helping much. So the right thing to do here is to consider ASPM as the consolidator. And essentially what that needs you to do is to understand your existing portfolio of tests, recognize that those will be different by project, that they may be using open source tools and many other things, and then obviously aggregate that into ASPM in a low touch format. What this allows you to do then is, if you wish, obviously get your consolidated view of software risk, and then use that as a way of identifying where there are overlaps, where tools are not working well, and so on. And of course, you can, set up the two-way integration with issue tracking systems. So that's really stage one, is just get the data. Then, of course, what you could do is after you've worked out what's working and not, then you can start to individually transition some tools. And that could be a transition which includes orchestration. So it could be that you decide not to replace the tools and you want to put them as tests run inside ASPM by orchestration, as I say, by running scans or by getting code and doing those things. But the advantage is that you can take your existing tools, you can pick up all of the existing issues, and then you can retain those remediations. I mean, if you've got 10 years of remediations in your favorite SAS tool or DAS tool or whatever, you've marked the vulnerabilities as remediated, why would you want to throw that away and start with a new tool? So that's the point, is start off by aggregating what you have and then start the process of consolidation or removing duplication. And that's when you can retain that historical data. And you no longer need the license for that tool that you're replacing, if that makes sense. So I've got about just a few more minutes. I mean, again, I'm going to go quite quickly as we're quite near time. But essentially, yeah, what you really need is a tool that works with many AST tools, that does the job properly. It has proper integrations, can show results in the IDE, in the pipeline, can integrate with your ticketing system in seamless ways. And obviously, it's flexible and gives you a change for the future. So these are very important things. We would like to propose ourselves as the leader in Appsec. You can see Synopsys in the top right for the 5th year in a row, in the very far extreme top right for the Gartner Magic Quadrant for application security testing. So we've been doing this for some time. And then finally, the other point to make is that if you want, you don't have to, but we do have other solutions that you can look at. So if you wanted to, we do have static analysis from Coverity and Polaris, our new SaaS platform, software composition analysis from the industry-leading Black Duck, new dynamic analysis, including from White Hat, and our new Fast Dynamic, and many other tools, Seeker for IAST, and multi-factor testing, and Defensix for fuzzing, and lots more. Okay, so we can certainly help you, but we're not proposing that you buy all the tools from us. What we are proposing is that you can use a flexible approach with the ASPM as an example of filling the holes. These tools are available in multiple environments, although I will just point out that Software Risk Manager, the ASPM solution, is on premises or self-hosted at the moment. Obviously, it's well integrated and it provides some good results there. So that really is the end of what I wanted to go through. We do have some questions. Shall I go ahead and how do you want to do with that, Leo?
Yes. Let me read them for you. Okay, so first of all, thank you very much, Matthew. I think the whole approach of consolidation of all the tools inside one application security posture management gives a very good understanding of the overall risk posture, because eventually there's a lot of noise, there's a lot of white or black noise, doesn't matter. But when you can see the overall picture, I think as a cybersecurity professional, it gives you more sense when or where you need to focus in your software development, and what are the defects that need to be mitigated accordingly. There are several questions, so I will read them out. So Matthew, how does the ASPM differ from SIEM? Like, do I need them both as a CISO application security?
It's a good question. The answer is probably yes. I mean, SIEM is doing something, monitoring systems, production environments, but other areas, and it's often around log monitoring and various other capabilities. So it's not really primarily focused on the application, on the SDLC, but it could cover some of those operational sides. And again, you might want to. It may be that you want to push some of those issues into your ASPM, or you may want to keep them separate. So the answer is there is some overlap, but not a lot.
I can also tell that the ASPM tool, as I see it as an application security professional, the ASPM is part of the development process. And the SIEM is more monitoring the production environment, also application, of course, but it's like a post, it's in the production when it's a bit too late. It's like let's do some control of compensating control or some kind of alert control, whereas the application security posture management is like a corrective control. Let's find those vulnerabilities in the early stage and fix them before going to production.
That's
Okay,
a point
but
well made.
as
Yes,
you said,
exactly.
need them both.
Yeah,
As part of the defense in layer, let's call it like that.
yeah, exactly.
Okay, so another question will be, what is the difference between vulnerability management and ASPM that you've talked about?
Yes, it's a good question. ASPM is really primarily about issue correlation, aggregation. What it is not about is necessarily replacing or adding new vulnerabilities from additional scans. So there's a big confusion in the industry, and you'll see a lot of ASPM tools talk about essentially getting public data and other things to add in yet more poorly qualified vulnerabilities into your already busy space of vulnerabilities. So you should leave that to SCA tools, the best in breed SCA tools, to produce low noise, fully qualified vulnerabilities, and not start trying to use public data to add yet more poorly identified vulnerabilities to it. So our ASPM does not add vulnerabilities based on package enumerators and so on. And I don't think that's useful. I think that's Black Duck that does that, and it does it in a well-defined way, or you may have your own favorite SCA solution that does that.
So a separation, what you are saying, like a separation in architecture of application security will be good thing to have your ASPM tool that will consolidate the full picture, and a specific tool for security testing, static code analysis, dynamic, interactive, IAC, infrastructure as a code, security scanning, and other, but everything will be aggregated through the ASPM. Is that correct?
Yes, well, that's one option. I mean, clearly, I do think some consolidation would be useful here. So, for example, and again, sorry to push our own solutions, but I am the expert on them. So, Black Duck, for example, does do software composition analysis, supply chain, container analysis, vulnerabilities, infrastructure as code, secret scanning, malware scanning, all in one place. But it's still only a small part of the whole process. You've got all those other types of tests that you're doing.
Okay, understandable. But it doesn't matter which tool you are using for scanning. Like you can connect each every scanning to the ASPM and
Correct.
find
Yes. I
those.
mean, clearly we don't support every single tool in the universe, but 150 different open source and commercial tools. So it's a large number, and we should probably be covering whatever you're currently using.
Okay, understand. Okay, Matthew, thank you very much for your insightful lecture. If there are any further questions, guys, please write them in the chat and the Q&A for each and every lecture. We are here to answer your questions. So please feel free to write them in the chat or in the Q&A. We are here to answer for every lecture that was part of this session. So going through the question over here, Avi, there is a question related to the threat modeling. Salim is asking, related to the threat modeling, if there is an applications like a tailored application with a lack of comprehensive documentation, how do you prefer threat modeling on that? What is your approach on that?
Ideally, you have people on the team that are familiar with it, that know it, and it's not documented per se, but they have a lot of information in their head, right? There's always organizational knowledge. There's always going to be that kind of thing. Very often, I have to do what I have come to call architecture archaeology, because every application has an architecture. It's just never usually not actually defined, and no one person knows all the different pieces of it. So you talk to this person, you talk to that person, you start getting a picture of all the things put together. And then you get everybody in the room to see that everybody agrees, or rather where they don't agree. Because very often, and I won't say every time, but very often, one person that is describing the system, it works this way and it works that way. And then you have the developer in the background who's like, that's not the way I built it. Or you have the product manager saying, that's not what it's supposed to do. So basically you're building the documentation, right? And this is why earlier you asked me about tools. That whiteboard is the most useful tool. And I'm not being facetious about using a physical whiteboard either. And I much prefer a physical whiteboard over digital tools. Digital tools are great for longer term persisting it and modifying it over time. But for the purposes of the discussion, there is nothing as powerful as having somebody from the back of the room jump up, grab the marker out of your hand, and start drawing on the whiteboard with you. And that is where you get the real insights, the real knowledge, and everybody in the room says, oh, I didn't know that. That is a sign of a really powerful, useful threat modeling session. And by the way, this often happens 20 minutes in. You don't even need to start talking about the threats. Just talk about what are we working on. And very often you'll find that. And I still remember recently a chief architect, we had a room full of security people and software architects. And the chief architect said, this is such a waste of time. Of course, the architects are building it in the exact way that you said. And the architects start looking at each other. We didn't build it that way. That's not what we did. Are we supposed to do that? That chief architect sat down and said, spend as much time as you want. Let's get this right.
Understood. Understood. Okay, thank you very much for that. Guys, if you have any further questions to Tamir and Matthew, please feel free to write them down in the chat. If you want a live demo or any other, of course, more info related to ASPM tools, you can, of course, contact Matthew directly. Matthew, if you want to write your email or any additional information related to past statistics and differences between ASOC and others. So please approach Matthew. He will be very helpful and supportive with whatever you need. So feel free, write on his email. So guys, if there are no further questions, I do want to thank our lecturers. Thank you, Tamir and Avi and Matthew. Thank you very much for the insightful lectures and insightful insight. I've learned a lot. Okay, and guys, please go to our LinkedIn page, be a member. All these session recordings and presentation will be uploaded to our LinkedIn page. And of course, everything is over there, so you can update with our next meetup. We are already planning it. It will be very interesting on the coming month and days because cybersecurity is evolving all the time. So keep update yourself and be part of our group and come to our meetup. Very insightful. So guys, thank you very much. It was a very good meetup. See you soon. Keep safe. So bye for now. Bye everyone.
Bye.
Thank you very much. Bye.